Imagine a future where the very building blocks of matter, protons, never decay. In our current understanding of physics, protons are remarkably stable, lasting for at least 10 to the power of 34 years, far longer than the current age of the universe. But what if they never decayed at all? What kind of universe would this create? Would it lead to eternal civilizations or something far more bizarre? To understand the consequences, let's first dive into why proton decay matters. Many theories beyond the standard model of physics predict that protons should eventually break down into lighter particles, though the timescale is immense. If protons could decay, everything made of atoms, stars, planets, life, would eventually disintegrate into a soup of subatomic particles. But if protons are truly immortal, then matter, as we know it, could persist indefinitely. Now, let's fast forward into the deep future, trillions, quadrillions, and even Google years ahead. In a universe where protons don't decay, white dwarfs and neutron stars wouldn't slowly vanish into radiation. Instead, they would persist as cosmic fossils of a long-gone era. Planets, if they managed to avoid destruction from cosmic impacts or stellar evolution, could theoretically exist forever, becoming wandering relics in an ever-expanding void. But the real game changer is black holes. Normally, black holes slowly evaporate over time due to Hawking radiation, eventually disappearing. However, if proton decay doesn't happen, then matter wouldn't break down into the tiny energy packets needed to sustain this evaporation. Would black holes become eternal prisons of mass? Or would new physics allow them to persist in even stranger ways? Even more fascinating, civilizations that conquer interstellar space might never face the natural decay of matter. Advanced species could build megastructures without fear of their materials disintegrating over time. Dyson spheres, massive space habitats, and even planetary-scale computers could last indefinitely, at least until external cosmic forces like rogue planets or gamma-ray bursts intervene. But what about energy? Even if matter remains intact forever, the universe itself is still expanding. Over time, galaxies will drift so far apart that communication between them becomes impossible. Stars will burn out. And without new sources of energy, civilizations will face an existential crisis. However, if protons don't decay, it opens up new survival strategies. Matter could be recycled in closed-loop systems indefinitely. Machines could be designed to function eternally using gravitational energy and other exotic methods to sustain themselves. Now, let's take this idea to the absolute extreme. If protons never decay, could this create an entirely different set of physical laws over vast time scales? The deep, deep future might see quantum fluctuations altering space-time itself, forming new physics beyond what we can imagine. But let's take a moment to consider how this impacts the far future of life itself. If protons never decay, biological and artificial life forms could persist for unimaginable timescales. However, survival would still be a challenge. Stars will eventually exhaust their nuclear fuel, leaving behind cold, dark remnants. Without proton decay, these remnants, white dwarfs, neutron stars, and black holes, would never fully disintegrate. Instead, they would remain as silent witnesses to a universe that continues expanding forever. In this distant era, civilizations would need to find alternative ways to harness energy. One possibility is the collection of residual heat from black holes known as Hawking radiation, which can take an incomprehensible amount of time to fully vanish. Another option is tapping into the gravitational interactions of cosmic structures, extracting energy from the slow movements of orbiting objects. But even with infinite matter, there is still the issue of entropy. Over time, the universe will keep stretching, cooling, and becoming more chaotic. The stars will go out, the galaxies will drift apart, and the cosmos will become a cold, empty expanse. However, if protons never decay, matter itself would still persist in some form, potentially allowing for the creation of artificial energy sources or unknown exotic physics that could enable the survival of intelligence for eternity. Now, let's explore something even more mind-bending. If protons are truly indestructible, what does that mean for the ultimate fate of the universe? In most models of cosmic evolution, the universe eventually reaches a state of maximum entropy, sometimes called the heat death. This scenario suggests that energy is so evenly spread out that no useful work can be done. But if matter is eternal, then it is possible that new structures could emerge on timescales so vast that they are almost beyond comprehension. Some speculative theories suggest that quantum fluctuations could give rise to new universes or reassemble complex structures over immense spans of time. If matter never decays, could it be possible for civilizations to go dormant, waiting for a future when energy conditions allow them to reawaken? Even more bizarre is the possibility that a civilization might engineer a way to restart the universe itself. If protons never decay, then the fundamental nature of reality may be different from what we expect. Perhaps advanced beings could manipulate space-time in ways that allow them to survive beyond the death of stars and galaxies, harnessing forces we do not yet understand. But there is also a downside to this scenario. If protons never decay, then certain cosmic processes that rely on this phenomenon would never occur. Some theories suggest that the eventual decay of protons is essential for the rebirth of the cosmos, helping to drive new cycles of star formation or cosmic evolution. Without this process, the universe might become stagnant, a place where matter remains, but nothing new ever arises. Even black holes, which are expected to evaporate over unimaginably long timescales, could behave differently in a universe where protons never decay. If their evaporation is affected by the persistence of stable matter, could black holes instead reach a state of equilibrium, becoming eternal structures of compressed energy? This also raises questions about dark matter, the mysterious substance that makes up most of the universe's mass. If protons never decay, does that mean dark matter is also similarly stable? Could it have even more profound implications for how galaxies are structured and how cosmic evolution unfolds? The ultimate mystery is whether the universe has an end point at all. If protons are truly indestructible, then perhaps reality itself is in an endless cycle. Could intelligence find a way to use this to their advantage, or would they eventually succumb to the limits of physics? If protons never decay, then even after unimaginable spans of time, the universe would still contain planets, stars, and remnants of civilizations long gone. But in a future where all stars have burned out and galaxies have drifted apart, what would be left? One of the most fascinating possibilities is that life, biological or artificial, could develop new survival strategies. Instead of relying on traditional energy sources like sunlight, civilizations might extract power from deep space phenomena. Gravitational interactions, quantum fluctuations, and even exotic particle physics could become crucial tools for survival. Some theories suggest that in an extremely distant future, quantum mechanics might allow for the spontaneous creation of complex structures, even intelligence, from seemingly random fluctuations. If protons never decay, then matter would always be available as a raw resource. Could future civilizations harness these fluctuations to rebuild themselves? Could they encode information in matter in such a way that even in a frozen, lifeless cosmos, intelligence could reemerge? Now, let's consider the strange possibility of time itself behaving differently over immense cosmic timescales. Without proton decay, there is no fundamental mechanism that forces all structures to break down. Could this mean that, given enough time, information is never truly lost? If so, then the idea of ultimate extinction might not apply. Instead of fading away, intelligence might persist indefinitely, adapting to new cosmic conditions as the universe changes. Advanced beings could develop ways to manipulate space-time itself, creating artificial energy sources, or even discovering new physical laws that allow them to survive the otherwise inevitable fate of the cosmos. But even if civilizations manage to endure for trillions upon trillions of years, there is still the problem of entropy. The universe will continue expanding, matter will spread out, and usable energy will become scarce. Without proton decay, would there be any way to reverse this process? One possibility is that if protons never decay, then some unknown process might allow for matter to collapse again under the right conditions. Could an advanced civilization find a way to gather scattered matter across vast cosmic distances, creating new sources of energy and potentially even reversing the expansion of the universe itself? Alternatively, if the universe continues expanding forever, intelligence might need to find new ways to exist in increasingly cold and empty conditions. Some physicists speculate that under extreme conditions, exotic quantum effects could allow for new forms of computation and existence, where consciousness could persist even in near total darkness. If protons are eternal, then perhaps intelligence can become eternal as well. Instead of being bound by the lifespans of stars or galaxies, civilizations could find ways to exist outside the normal flow of time, stretching their experiences across unimaginable eons. In the end, the question of whether protons decay has profound implications not just for physics, but for the ultimate fate of everything. If they are truly indestructible, then the universe might never truly end. Matter will remain, and with it, the possibility that something, perhaps intelligence, perhaps new physics, will always exist. But whether that future is one of endless potential or infinite stagnation remains one of the greatest mysteries of all.